Hello everybody, Chris here, and in this video I'm going to be showing you guys a crash course on Godot 4, which is currently in its alpha. So this is going to be some of the new features that you would find in Godot, and roughly how to assemble a game. So we're going to be assembling exactly what you see on screen here. We have a character that can move around the screen. We have NPC cows, as you can see. They like to randomly go wherever they want, and they blink sometimes. We also have some objects you can collide with, like the chest on the ground, walls, and these houses that are actually composed of multiple layers. As you move around the screen, the camera is going to follow your player as well. And we're going to be covering all of this in a single video, so feel free to break this video down into multiple parts. I have it sorted by chapters, and you can take your time in finishing everything. So for this tutorial, I'm going to try assembling it through the Sproutlands asset pack. I'll go ahead and put the link to this pack in the description, and we'll just be using the basic edition, which you can download for free to test out. Okay, so there's the art pack we're going to use for this video. Let's go ahead and start a new project in Godot 4. So when you open up Godot, of course, you have the project manager. So to create a new project, go ahead and click new project over here on the top right. If you've used Godot 3, you may notice that they changed the renderer in Godot 4 to Vulkan. So since this is going to be 2D pixel art for this tutorial, I'm going to be using Vulkan Mobile for this project. Everything's 2D, so there's no need to have it be on Vulkan clustered. So just find the folder you want to place your project into, give it a project name. So I'll go ahead and call it Godot 4 Crash Course, hit create folder. So you'll see this immediately adds the folder onto the end of the project path, and then we can hit create and edit to start. So when we enter our project, it's going to default to the 3D view up here at the top. We can easily switch that to 2D view just by clicking on 2D. And until we write any scripts, this is going to be our scene viewer. So before we get into it more, let's just add the art assets we downloaded into the project. So I'm going to right click here on where it says resources over in the file system and do open in file manager. Now I'll create a new folder in here with right click, new folder, and I'm going to call this art. Let's enter into the folder. Going to minimize the Godot window here. And now let's double click on the zip file wherever you downloaded that for the Sproutlands pack. And if we look in here, we have all the characters, objects, and tilesets and stuff. Let's bring the entire folder into the art folder. So this way of organizing it, if you ever add any other packs for your game, you can just have them be separated here by the pack name. Now if we switch back over to the Godot window, you'll see the art is included here. We can expand down to the characters, objects, and tilesets. So in Godot, everything is organized in scenes and nodes. So you can think of a scene as an object or a level that you can load into other scenes if you want, or they can be their own standalone scenes. But in those scenes, everything is composed of nodes. So if you want to have a 2D sprite, that would be one node on your scene. If you want a collision shape, that would be another node that composes your scenes. And then if you wanted to create a copy of a scene, it would simply be dragging and dropping the scene file from your file system wherever you need it in your other scenes. So in Godot, an object that you want to be able to create a copy of is saved in your project as a scene. Scenes can have other copies of scenes inside of them. And for each scene, you would compose it with a group of nodes. So a node could be something like a sprite 2D, a text field if it's in the user interface category, or a collision shape, which defines where one object would collide with another object. So to create our first level, let's just click on 2D scene. We'll get a node 2D. So a standard node 2D is kind of the basis of any other 2D node that you can add in your project. And every 2D node is going to have these features you can see over here in the inspector, such as having a transform, which contains a position on the screen, and this ordering tab over here, which you can use to determine whether something should display on top of another object or underneath it. But as you'll see later, as sprites move around the screen, sorting objects through a Y sort enabled on a parent node is a good way to make it so that if a character moves above an object, then it will hide behind that other object. But when it's lower on the screen, for a 2D game, of course, then it would show on top. So this 2D node, I am going to just hit F2 on it and rename it to be game level. So now I'm going to Control S to save it, and we'll put it in our project. We should probably create another folder for these levels. So I'm going to create a folder, and I'll just call it levels. Or level. Go ahead and hit save. I'll just rename that to levels because I think that makes more sense. So you'll see that this actually saves as a .tscn file. So when you see that, you know you're looking at a scene. Any scene, you can double click on it to open it up. and that will show you all of the nodes that are composing that scene. So in this scene, we could add other scenes to it, such as a character object. So let's go ahead and create the character as a new scene. I'm going to click this plus button over here next to where it says game level. And this time, rather than clicking on 2D scene, which is just going to give us the standard node 2D type, let's actually make the root of this character scene a character body. So let's hit other node, which will bring up the create new node window, which we can search for any node we want to make the root for our character. So if I click node 2D here and expand that, we can come down here. So if I click the drop down on node 2D, we can expand this, and we're going to be looking into collision object 2D, physics body 2D, and specifically a character body 2D. So this is a new type of node in Godot 4, which helps handle the collisions between your character object, which is going to move around the screen, and other character objects or static body 2Ds, which would be stuff that does not move ever, which will handle the collisions between a character and other objects like static body 2Ds or other character body 2Ds or dynamic rigid bodies. So let's use character body 2D here, hit create. And you'll see that makes it the root node here for this character scene. Now note that because the character body 2D inherits from node 2D, we can look in the inspector and you'll see that the node 2D functions are still over here. So the character body 2D also has a transform and an ordering tab. So you can see under node 2D here that it still has its own transform and ordering tab. So this is kind of important because sometimes you'll make a hierarchy of nodes, and a child node, one that's nested underneath your parent node, will actually inherit the position of the parent node. So for this character body 2D, we're going to leave it in grounded mode since the characters in this art pack, they walk on the ground, they don't float above it. So this motion mode makes sense instead of changing it to floating. If we look in the scene hierarchy, there's this warning sign. If we hover over it, you can see that this node has no shape, so it can't collide or interact with other objects. So we should add a collision shape for the character, but first we should actually add a sprite so that we know how the character looks to begin with, so our collision shape makes sense. So I'm going to right click on the character body 2D, and let's add a child node. I'm going to search for sprite, which will help us find sprite 2D. Let's create, and then if we jump into the art pack, let's drill down to the characters. And then we can click on a basic character sprites. You can see over on the right a preview of the image file. Let's add it to Sprite 2D. So if we click on Sprite 2D, there's this texture field. We just drag and drop basic character sprites into that texture field. And now we can kind of see the character, but we have a bunch of problems going on here. First off, the image looks blurry. Because we're dealing with pixel art and we have the wrong rendering settings, the character looks kind of blurry. So to fix that, let's go up to Project Settings. And then if you scroll down from the top to rendering here and click on textures, you can see default texture filter. For pixel art, you want to set that to nearest. So change that as the default and it will update for all of the art in our game. If we hit close, you can see that the pixels are now crisp, which is exactly what we're looking for. Okay, so second problem. We see the entire sprite sheet at once, but what we actually want to do is just split it into separate sprites for separate animations. So there's actually a whole bunch of ways to split up your sprite sheets for your animations in Godot, but let's do it this way. I'm going to click on Sprite 2D. If we go over on the right, there's this animation tab. Let's go down here. And now we want to set the number of H frames and V frames to match our sprite sheet. Basically, to take one giant square and make it into 16 smaller squares. So I'm going to put 4 for H frames and 4 for V frames because this is a 4x4 grid. So 4 and then 4. And now it's only going to be showing the first frame in that set because our frame coords 0, 0 means we're at the top left of that sprite sheet. So now before saving this character scene, I'm going to click on the character body 2D and I'm going to rename it to be player cat. So that it's a little bit more specific than just the name of the node. Let's hit Control S, and I'll create a characters folder, create folder, characters, and then let's save this player cat scene into here. So now just to see this scene inside of another scene, let's add it to the game level scene. So if we click on game level, you could right click and instantiate a child scene from the list of scenes in your project. That's one easy way to do it. Another way is to expand characters and then just drag the scene in wherever you want the cat to be. and then let go, and you'll see it's added to the scene hierarchy. So now we have a player cat scene inside of our game level scene. And this player cat scene, we can click here to jump into the original scene that's saved in our project, or the copy where everything is created as an instance from. We can see in this scene that there's a node hierarchy. So scenes are composed of nodes and other scenes, and in any scene, you can find nodes. Okay, so I'm gonna hit Control S to save the game level scene. Let's go back to player cat and let's add a collision shape. So I'm gonna right click on player cat, add child node. I'll type in collision so that we can find collision shape 2D. Note once again that collision shape 2D inherits from node 2D, which inherits from canvas item. So anything as you go down the chain, it still has the functions of everything above it. So whatever a node 2D can do, a collision shape 2D can also do. So let's create this collision shape, and you'll get another warning sign for the collision shape because a shape node actually needs a shape resource attached to it. So the shape resource is going to be stored over here in this shape field. So if you click on the dropdown, you can choose a type of shape for your character. So something like rectangle shape, circle shape, or capsule shape is probably going to make the most sense here. For simplicity's sake, I'll just do rectangle shape 2D here. And when we create it, you can see that it is too big for our character. So we're going to want to adjust it. So if we click on the rectangle shape 2D here, you can see that there are settings. Let's change it to something more like 5 by 5 pixels. So you can click on the rectangle shape 2D to have settings you can set about it, such as the size. So you could set it to 5 pixels by 5 pixels manually here. But the more intuitive way is probably just to adjust it using these circles that appear around your collision shape. So you can pull these out and just set the size and shape of your collision shape by controlling the rectangle on your character. So something like that could be good. Maybe I'll pull in the edges 1 more pixel. Okay, so let's go ahead and try running our main game level now, which has the player cat in it. So I'm going to hit this play button in the top right hand corner. And when we hit play the project, it's going to say that there's no main scene. So the main scene is just the scene you want the game to start with. So I am going to hit select, and we will find the game level scene in our project. Click open, and now it's going to launch this scene. So I'm going to try using WASD and up, down, left, right to move. And you see that nothing really happens yet because we don't have a script attached to our character, which would make it move. So let's hit the stop button in the top right. Okay, so now to add a script to the player cat, let's click on the root node here. Go over to the inspector, and down at the bottom, there's this area here, script, empty. So I'm going to click on the drop down, hit new script. This will create a GDScript inheriting from character body 2D, which means that the script can do everything that the character body under it can do already. So it's building on top of what already exists. And we're not going to use the template for character body 2D basic movement. This adds extra stuff like jumping, which right now don't actually make sense for the character. So we'll just write a couple lines from scratch. And for the path, you can see that it defaults by storing the Godot script into the same folder where our player cat scene is. So I'm just going to stick to that convention and hit create. So now we have the player cat Godot script inside of the folder. You can also see this icon next to player cat showing that a custom script has been attached to this node, which gives it the extra functionality. So anytime you want to edit the script, you could just click here. You don't necessarily have to find it in the file system. So in order to move our character around, we're going to put the code that causes that to happen inside of the physics process function. So physics process will run a certain number of times per second, along with every other object that has a physics process function. Everything on your screen is going to get calculated and moved at roughly the same time with physics process. So anything that's going to be moving and colliding, you generally want that code to be in physics process. So you do need to put in this parameter delta. I put the underscore because we're not going to be using the delta right now. So an underscore in Godot can represent a unused variable so that you don't get the warning. But the delta is the time since the last physics process updated. However, when we use the move and slide function, it's going to automatically take that into consideration, so we don't need to manually pass it as a parameter. But when we get to the move and slide function, which is actually what finishes the calculation and moves our character around the screen, it automatically takes into consideration the delta, so we don't need to worry about that manually. So first off, we got to get the input direction. So to do that, I'm going to create a new variable. So var input direction, and this is going to be equal to a vector2. So a vector2, you can just think of it as it has a x and a y value. So x in our game is going to be horizontal movement, left and right, and then y is up and down. So we don't need a vector3 because this is a 2D game, not a 3D game. So there's no z-axis. Don't worry about that. So to calculate our input direction, we need to know the keys that are going to be responsible for left and right movement. So when we're doing keyboard input, WASD movement, pretty standard for games these days, that would be A and D on the keyboard. But we're going to get the action, not the keys directly. So to do that, you can type input.get action strength. So in terms of a key press, this is whether it's pressed down or it's not pressed down. And you can see that the action is a string name. So I am going to put right here for the first action. And we're actually going to subtract input.get action strength left here. The reason for that is that our right arrow, or D on the keyboard, is going to cancel out our left movement key, which is A. Or you could have it set up as left arrow on the keyboard if you want. So basically, if you have them both pressed down, then the character won't move. But if you have right pressed down, then this is a positive value. It'll give you a positive one. But you can see the subtraction sign means that pressing down the left key represents a value of -1. So if our positive direction is right on the x-axis, then that's going to mean that if we have a positive value, we're going to move right. And if we have a negative value, we're going to move left. So the same idea applies to moving down and up. So import.get action strength, and I'm going to call this down for the action name. We haven't actually set these action names yet. You can set them to whatever you want. Just make sure that in the project settings, it matches the string values here for it to work. So down is actually going to be our positive input for the y-axis. So a positive value corresponds with going down on the screen, and a negative value corresponds with going up on the screen. The last action needs to be input.get action strength, and then up. So this will get us our input direction if we have those actions set up. So to set up the actions, go to project settings, input map, and then we need to add action names that match these in the input.get action strength. So I'm going to type in right and hit enter, left, enter, down, enter, and up, enter. So that creates our 4 actions. And now these actions can have multiple types of input attached to them. So you might have a keyboard input for the action, and you might also have a controller input. So that's why you get the action and not the direct key press directly, so that you can account for other input types. For today, we're just going to be using the keyboard. So I'm going to hit plus over here to add an event, and that event is a key press. So for the right action, when we want the character to move to the right, what key do we press? So that's going to be D if you want to use WASD movement. You could also use right arrow if you'd rather use up, down, left, right arrows, or you could even add both if you want. So let's go ahead and hit OK now that I chose D by pressing D down. I'll add the next key. So it's waiting for us to press the left key. So I'm going to hit A. Okay, use physical key code A. Okay, you can see that gets added to the list here. Add it again, S for down. Okay, add again, W for up. Okay. Okay, so now let's go ahead and hit close. And just to test that this is working, I'm going to add another line of code, which is going to be print input direction. So when we use the print function, it's going to output a message down here, and the message is going to be the values of our vector2 input direction, the variable. So let's go ahead and hit play, and you'll see that on every physics update, it's going to print our vector2. And then when we press WASD around, you see those values change. So we can use those values to control the direction of our movement. So let's hit stop now. And we need to get a velocity for our character to move. It's going to be the direction times the speed we want to move. So how do we know what speed we want the character to move at? Well, that's up to us. We should probably create a variable up at the top, especially one that can be customized in the inspector without having to come into the script every time we want to change it. So I'm going to add above all of our functions on line 3 right here. And this is going to be different than Godot 3. They changed the syntax a bit. So at export makes it visible in the inspector, and then var move underscore speed. We can put a colon and define what type it should be. So I want it to be a float, which is a number that can have an optional floating decimal point, and then equal to, let's say, 100. Okay, so now if we click on player cat in the scene hierarchy, then you'll see this move speed variable shows up here. So anytime we want to change the move speed, we can just click here and type in whatever number we want for testing. Okay, so now back in the script here, we can update our velocity. So velocity is actually a built-in variable for the character body 2D. So if we do velocity, it actually already knows what we're talking about because the character body has a velocity. And we'll do equal to input direction times move speed. Okay, and we can get rid of this print line because we've already made sure that the input direction works. So now the last thing we need to do here to move our character, at least for right now, is going to be to use the move and slide function. So this is super easy in Godot 4. You just type in move and slide. There's also move and collide, which works a little bit differently, and you do have to pass some parameters in for that one. But move and slide, basically, if you come against a wall, but the character can still kind of move, then it will slide along that wall rather than just being stopped altogether with a full-on collision. So let's get rid of the move and collide. Move and slide is going to make more sense for this character, at least for now. So let's click on game level. I'm going to hit F1 on the keyboard to switch to 2D view. And let's go ahead and hit play and test how our character can move around the screen. W for up, A for left, S for down, D for right. And it's all working. We can also press multiple keys at once. I'll try A and D at the same time. And you can see that actually stops the character altogether. And same for W and S. So it's working so far. There's some problems, one of which the camera is way too far away from the character. We can't really see much. Secondly, there's no animation for the character, which is kind of boring. So now to fix the view of our game and make it so that things actually appear much more zoomed in, so we can actually see our pixel characters, let's go up to Project Settings, General, and then we want to find Window here, Display Window. So let's set a custom viewport size. I'm going to do, let's say 1920 by 1080. So this is going to be how much space on the screen you want the window of the game to take up when you hit play. I'm on a bigger monitor right now, so this is still going to be only like half of the monitor. And we also want to stretch the game and make it so that it appears bigger than it actually is. So I'm going to do stretch mode, canvas items, and I'm going to do scale. Let's set it to 4 for right now. Okay, let's go ahead and hit close. I'll hit play. And as you can see, everything is much, much bigger than it was before. Which actually allows us to see the character and, when we get around to it, tile map, objects, stuff like that. Okay, so now that we can visibly see our character, let's actually add some animations to it so it's a little bit more interesting. So I'm going to close out of game view, and on the player cat scene, I'm going to right click on the base character body and add a child node. Search for animation. And then there's going to be 2 nodes we're going to need for the scene. One is animation player and one is the animation tree. So let's just add both of those in real quick. Now to create the actual animations, you do that on the animation player. So if you click on animation player, you should see this new window animation down at the bottom. So we want to jump into that and then click on this animation button and choose new animation. Give it a name. So I will start with walk right and then hit enter. So how animation works in Godot is through keyframes. So almost any property in Godot, you can actually attach a keyframe to. So you might notice when we have the animation window open, if we click on something like Sprite 2D, there are now these keys that appear next to each property. So those are what we can change at certain points in the animation through this animation window. If I start cycling through the frame on our Sprite 2D, you'll notice that this actually changes the animation frame already between the ones that exist inside of that sprite sheet. Since we separated it by horizontal frames and vertical frames, it's already in its separate rows and columns. So for these animations, at least for now, we just need to change the frame number. So let's do add track, property track, Sprite 2D as the node we're targeting, and then go down to frame, hit open, and now we have this track where we can edit the value. So to add a sequence of frames to this track, just click the keyframe button where it says 0, click on the keyframe, and that will add the first frame into our animation sequence. So you'll notice that the frame also auto increments to 1. So if we want frames 1 to be added next inside of our track, just click on the keyframe again, and one more time. And that will give us the 4 frames for our animation. So now we just need to control the duration of this animation. So over here on the right by the little stopwatch, I'm going to set this to 0.4 for a 0.4 seconds animation. I'll click on the loop symbol, which is right to the right of that, and then we'll hit play. So we can see that this is an animation for the character. This might not be actually displaying correct. So let me take a look at the sprite sheet. If I look at the first 2 frames, that actually looks more like a idle animation. And then the next 2 are more of the walk cycle animation. So I think the first 2 frames on every row might actually be for idle. And then the last 2 frames are for walking. So to fix that, I'll just simply remove the 2 idle frames. So that's frame 0, frame 1, select them and then delete. And then I'll move the frame 3 over here to 0. And then I'll try frame 2, which is actually the 3rd frame in the sheet, over 2 times 0. And frame 3 over to 0.2. So this will make them 0.2 seconds per frame. Let's go ahead and hit play and see how that looks. So that might work. Let me go ahead and make the idle animation as well. So I'll click on Animation, New, Idle Right, hit Enter, Add Track, Property Track, Sprite 2D, Frame, and then you can also add the values by right-clicking here and doing Insert Key. So let's click on that keyframe and set the value over to 0 in the inspector, and then at 0.2, I'll right-click, Insert Key, click here, set it to 1, and hit Enter. And let's make the animation 0.4 seconds over on the right, and loop. So let's hit play and see if that looks a little bit better. So you can see this is probably an idle animation, and this is definitely a walk cycle animation. So I think that this is more what the actual creator of the pack intended. Okay, so if we take a look at the sprite sheet one more time, first off, I wasn't actually creating the idle right animation there. That was more like idle down and walk down. But the next 4 frames are walk up, and then we have walk left and walk right. So let's go ahead and duplicate these animations and get them all set up. So first off, for this idle right, let's rename it to idle down. So you can click on animation, rename, idle down, and then we'll click on the drop-down list, walk right, animation, rename, idle, walk down. And now let's duplicate them. So I'm going to click here, duplicate, and next in the list was walk up. So walk up, enter. And if we click on these keyframes, we can just add 4 to them because I already know that there's 16 frames. Each row has 4. So if we add 4 to this number, it's going to be the first frame and the walk up. And then if we add 4 to this number, which will make it frame 7, then that will be the second frame and walk up. So do that and then hit play. And that's all you need to do to create the walk up animation. So let's do the same thing with idle down. Duplicate, animation, duplicate, idle up. Click on this, add 4 to the number. The next keyframe, add 4 to make it 5, hit play, and then we have our idle up. So just do it for idle left and walk right and idle right. So let's duplicate idle left. So let's add an extra 4 to make that 8, and 5 becomes 9. So I'll hit play, and then we have idle left. I'll duplicate this one more time, idle right. Click here, add 4, click here, add 4 for 13, idle right. And now for walk up, let's make walk left, click here, add 4 for 10, and then 7 becomes 11. We hit play. And one last time for walk right. So I'll click here, add 4, click here, add 4. Okay, so that is all of our animations for this character. So you're probably wondering, how do you actually determine which animation is going to display at any given time? So there's several ways you can do that. But one of the more visual ways would be to use the animation tree in combination with the animation player. So the animation tree, if you click on it, will require an animation player over here on the right to pull all the animations from. So I'll click Assign Animation Player so that we know where the animations are coming from and which ones we have available. And then we create an organization for the animations, which one animation or group of animations in a blend tree can travel to another animation or another blend tree in order to display the correct animation and direction for the animation at the right time. So for the tree root, click here, and then we will choose a new animation node state machine. When we do that, we'll get this node graph. So we have 4 idle animations and 4 walk animations that have a direction. So for direction-based animations, in this case, up, down, left, right, it would be perfect to right-click and add a blend space 2D, because we can add the direction that the character is either moving or looking at in order to determine whether it should display up, down, left, and right. So I'm going to add a blend space 2D, and let's just rename this. Oh, whoops. And then click on the name of it and rename it to idle. And then I'll right click and add a blend space 2D. I'll click here. I'll rename it to walk. So let's add paths between these blend groups so that one can transition into another. So I'm going to click on this connector button, and then I'm going to left click on idle and connect it to walk. I'm going to left click on walk and connect it to idle. And I'm also going to connect start to idle so that we can have it automatically enter an idle state when the game starts. So right now nothing's going to happen. In order for the blend space 2D to work, we need to click on the edit pencil next to idle, and then we'll see another graph. So this has X and Y. We'll get X and Y inputs from our script in order to control which animation it's going to show in here by basically whichever animation is closest to the XY values on the graph is going to be the currently displaying animation. Now, before we do that, I'm going to change the Y max here to 1.1 and the Y minimum to -1.1. So if we put the Y at a value of 1.1 for going up and down, then that will make it slightly prioritize left and right animations in your game over up-down animations. So if you're pressing 2 directions at once, it would show the left-right animation. So this is if you want to have a tiebreaker, which animation should be prioritized. Anyway, to add the animations to the graph, click on this icon with the pencil, click up here, and then choose Add Animation. Now, remember from earlier that down is actually up on the graph, so I'm going to choose idle down here. And then down here, I'm going to do add animation idle up. Now, if we click on them, you can see that the point value is 0, 1.1. And down here, I'm having it set to 0, -1.1, as I just previously mentioned why I was doing that. So next, let's add in the left-right animations. So over here at -1x, let's add animation idle left. And then over here at the right, idle right. So now you get an import value, and whichever value is closest is going to be the idle animation that it shows. So let's jump back out and do the same thing with walk animation. So I'll jump in here, set this to 1.1, this to -1.1, add the walk down at the top, add the walk right on the right, walk up on the bottom, and then walk left on the left. Okay, so now let's go ahead and click on AnimationTree, set this to active. So before we hit play, we can take this transition here and set it auto advance so that whenever we enter the start of this state machine, we just automatically start at idle. Now, for going between idle and walk, we'll actually set that up in code. So we won't automatically switch between these states, but we will script it so that we can switch between the states when we want to. So now if we hit play, we should see the idle animation. It's showing idle right, though, when we have no import values. So we might want to customize that so that we actually have it start with idle down. So if you want to control which direction the character is going to start with, you can click on the animation tree, go into idle under parameters, and you'll see the blend position. This is actually the value we're going to set in code as our physics process updates. But let's take the Y and set it to, let's say, -0.1, hit enter. Okay, so now let's jump into code and make it so that we can set the value of the parameters on that blend tree, which if we expand the parameters in AnimationTree, you can see idle, blend position. This is values we can edit in code. So you can actually get the path to this specific property by right-clicking on it and doing copy property path. Now let's open up the script in the scene inspector. And I'll just go up here and add a couple lines and Control V, paste it in. So you can see parameters, idle, blend position. That's something we're going to want to set for the animation tree component. For right now, I'll go to the start of the line and add a comment with Shift 3. So we'll just remember that for later. Now we need to get a reference to the animation tree in our code. So I am going to do @onReady, which means that when the script starts, we get access to this node that is in our scene. So var animation tree equals $animation tree. So what this means right here is that it's going to look at our scene and it's going to find the object named animation tree, letter for letter, caps matter. And it's going to store the reference to that in this animation tree variable. So then we can use it in our script. So I'd like to control the idle animation and make it start facing down. So if you use function _ready, then you can set some stuff up when the script runs. So let's use the animation tree, and I'll do animation tree dot set. And then we need the parameter name, which is this right here that we copied from the inspector. So I'm just going to paste that in there. Parameters idle blend position. And let's set it to whatever value we want. A good idea would be to make that a variable that we just have up here at the top of the script. We could even make it an export variable so that we can edit it in the inspector whenever we want. So starting, and we'll make that a vector2. So that equals vector2. And I want 0 for the x. And I'll make that anything above 0 for the y. So I'll just put 0.5, or we could just say 1. Actually, it shouldn't make a difference. So now let's take this variable, put it in here for what we're setting the animation tree direction to as we start. And then let's hit play and test. So another thing we've got to change for our animation trees is the blend mode. So if you open up your animation tree for the idle blend tree or the walk blend tree, the default is set to continuous, but we actually want to make this discrete because the only thing we're changing when we go between these is to directly change the animation being displayed. So if I move this value selector for the blend position, you see this over here, then this will actually make it display correctly because it's just immediately switching. And we need to do the same thing over for the walk. So change it from the continuous line to discrete. When you're doing pixel art, generally it's discrete animation. So now if we go ahead and hit play, we can see the idle down animation is correctly playing as our default. And if I was to go to play a cat and let's reverse that, I'm going to take the starting direction and make it -1. Let's hit play and you can see it's facing up now at the start. Okay. So we at least know that we're setting the value correctly. So now we just need to set up some more times where we change the value. So over in the code, I'm going to put in a new function that whenever we get move input from the direction, we can use that to update the animation parameters, which is going to make it so that the character is facing the movement that matches our user input. But I'm not going to have it actually change when there's no user input, which means that if you go idle, you're not touching the keyboard, then it's just going to face whatever direction it was before. So we'll update the same value for the walk and idle blend trees. Since they work the same way, it's based off the movement input. So just update them both at once. So now we can take this, and when we have this ready up here, let's just paste that in. And we'll add the parameter, which is starting direction. So that'll be how we take care of that at the start. But then whenever we get the input direction, we also want to update the animation parameters. So I'm going to paste the function, and then we're going to take the input direction and use that as our move input for the update animation parameters. So now let's hit play and see how that changes things. So if I start pressing keys like this, you can see that the blend position is being set on the animation tree, and we can change our direction whenever we press the right key. So the last thing we need to do is to make it so that we can go between the different animation states. So you'll see in the animation tree, we have idle and walk. So we need something in the code to tell the animation tree to travel between the blend spaces at the right times. So that's going to be based on whether the character is moving or not. So to do that, there is a playback component that we can call a state machine inside of the animation tree. So I'll just paste in the line up here to get that on ready. So after we have the animation tree, we can get the playback parameter from the animation tree, which is our state machine. And this allows us to change the state, or which blend space we're going between, on the state machine graph. Basically, it's getting this component right here, animation node state machine playback. With that, then we can do state machine.travel and the name of the blend space we want to go to. So this function down here, pick new state. If the velocity is not 0, then we walk. Otherwise, the velocity would be equal to 0, in which case we just idle. So as long as we do this, basically every time we move, so I could do this up here, just pick a new state after we move and slide, or before. Probably doesn't matter too much exactly at the timing for now. But we can go ahead and hit play now, and we'll be able to go between the different states. So if we left click, you can see that now it's running, right click and hold, and we're running to the right. But as soon as we have no velocity, it goes back to an idle state. And that is basically how we can switch between different types of animations and directions for a character in Godot. So at this point, we have a character that can move around, but there's really no game world for it to move around in. So let's add in a tile map. I'm going to right click on game level, and then I'm going to add a child node, search tile, and you'll find tile map here. So a tile map can draw on a bunch of tile objects from a tile set. So it's really handy for being able to build a map from basically an image sheet. So if I look in the Sprout Lands pack, these tile sets, those are what we'll use in order to create our tile map. So with tile map open, down here at the bottom, we have tile map, and then in the top right, inspector tile set. So we want to create a tile set. So I'm going to click new tile set. When you do that, there's a new tab called tile set down here at the bottom. And to create a tile set, we need to add an image in here that we will use for our tiles. So let's start with the grass image. I'll just drag this over here. It'll say Atlas texture was modified. Do you want to automatically create tiles? Let's do yes for simplicity. And you'll see in Godot 4 that it will automatically slice up the image into the individual tiles that we can use for drawing on our tile map. So now if we click on tile map, you can see our tile set over here is available, and we can left click on a tile and then left click on our screen to start drawing that tile. So you can select any grass tile you want to be the base ground and just add some variant tiles for some options. You can also select a whole bunch of tiles and then use this random tool. So if I select all of these and then I start drawing around, then you can see it's actually going to randomly select between the tiles that I have selected. So usually though, when you are drawing your tiles, you don't want to have too many of the fancy tiles that have these extra information. You just want to use those sparingly. So if I hold shift and I left click on this one down here, then I can have all of them selected, including the normal grass tile. But even if we can have that normal grass tile, it doesn't appear enough. So what you could do is turn off the randomness. And now let's take the rectangular box tool with the center grass tile, just the normal one. And I'm going to drag a huge box around our scene that can be our base ground. I'll actually make that even bigger. So now to make these randomly appear when we draw, but not on every tile, in order the random selection, and let's take the scattering and make that something like 20. So now if I use the pencil tool and I draw, it'll appear, but not on every tile we hover over. So if I hit Control Z and I select all 10 now, I can draw with the pencil tool and kind of go around, and it will sort of randomly distribute the tiles that I want to randomly select from. So we get a interesting variation of the tiles added onto our grid automatically. We can also Control Z that and then use the fill bucket and just select this whole thing at once, left click, and there you have it filled in, all of the original grass tile with randomly selected tiles. So if I hit Control Z now, I can increase the scattering further to make it less likely. So I'll do 50. Now let's left click here. And I think it appears less. So I'm actually not totally sure if this is a % chance out of 100. So the higher you set your scattering value, then the less likely it's going to appear when you fill in. So if I left click here with the scattering of 50, you can see that some of them are filled in, but most of them remain the original. But if you have a scattering of 0, then left click, every single tile gets filled. So just play around with your scattering settings, and that can be an easy way to kind of get a randomly generated map here that you can use as your base. And then for anything else like paths, you can draw that on top when you need something that isn't just a random detail. So I'll go ahead and turn off scattering. For these other tiles that actually have some transparency in them, what you'd want to do with them is put them on a second tilemap layer. So if you look in the inspector for the tilemap layers down here, we can name the first layer base ground. And then I'm going to add an element. We'll call this top ground, I guess. Hit enter. And now, when we're selecting these tiles, we change base ground to top ground. So we're showing where we're going to be drawing them on. You click the tile you want, and then you can add it to the level here. So if I click off something else, you can see these tiles actually vest on top of the back tiles instead of being their own thing. So if you don't have layers, then it would look something more like this, where you just have these transparent areas, and that's kind of weird. So sometimes with tiles and objects, you have to layer what you're trying to create. So let's go ahead and create some more tile sets. I'm going to click on tile set. I'll just drag hills in here, hit yes to auto create them. Tile dirt, add it in, auto create. Water, auto create. Why not just keep going? Wooden house, auto create. And fences, auto create. So definitely this aspect of Godot 4 is a lot simpler than it used to be, for sure. Okay, so now with these cliff tiles, we might want to have another layer. So make sure the second one is top ground, but then I'll add a element and I'll call this high ground walls and hit enter. Okay, so now when we add stuff like the hills walls, we probably want to make these tiles so that they can't be walked into. So let's work on collisions. I'm just going to add some hills over here, and I'll add the extra stuff over here as well. Then you'll see I'll be able to walk right into it. Oh, well, we can't even see the player actually. So let's go ahead and fix that actually. So for the tile map, I'm just going to make it so that the ground always displays under the player by changing the Z index in the layers. So base ground, I will make -5, hit enter. Top ground, -5, hit enter. So the player will always render on top of those objects now because the Z index of the player is 0. So it ranks higher. So let's hit play now. And then we can move our character around. But you can see I can just walk right onto the cliffside, which is not what we're looking for. Also, I'll try to add in some extra grass. So let's click on tile map. So we want base ground and rectangle select. I'll just add in a whole bunch more stuff so that we don't see the edge of the map, at least for right now. But for these hill tiles, we need to make it so that they have collisions. So how do we do that exactly? And I'll show top ground so that we can see the hill. So if you click on tile set, then we want to add some extra properties to these tiles so that there's an actual collision. So there's this paint properties button. If we do select properties and then we choose physics, well, we can't choose physics yet because we haven't actually created a physics layer. So let's do that. In the inspector for the tile set, expand physics layers, add an element, and you'll see collision layer and collision mask are both set to 1 here. So that's the default collision layer. So the player is already looking for collisions by checking if anything exists on collision layer 1. So if we paint properties down here and add these tiles to collision layer 1 by referencing this physics layer, then they should collide with the player, or rather the player should collide with them. So select a property, physics layer 0. That's the first item in this list here. And you can left click on a tile and that will automatically create a box shape around the edges for a collision. So if you just want it to block out the whole tile, just left click, and let's go ahead and hit play and test that collision. So we try to go here and our character actually can't walk through the wall, but it can still do the other areas, of course. And we don't want to make it so that this area can be completely unwalkable, because the only area that should be blocked is probably this edge here. So hit stop and go back to the tile set. Let's add in a more detailed shape for these edge areas. So I'm going to left click on this tile, but then in this editor, I'm going to drag the corners over to the left so that it's actually only blocking on the far left area of the tile. So if I left click our next one, I guess that actually automatically created that there. So if I left click here, it's going to do the same thing. Let's use the move tool and drag this over. So click on the tile you want to copy that to. And there's also this edit points tool. So I'm going to click on this tile, which this should be over here. And I'm going to drag these points to the right, kind of like so. You can also add more points. So if I do click, 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 and then over here as well, and back to the first one, then we kind of have two collision shapes inside of one. Actually, we could probably just make this whole thing one shape. It doesn't have to have two shapes, though you could do that. I'm going to remove everything. And then let's use the manual add tool. And I'm just going to left click the three corners over here, and then the inside loop, something like to here, over here on the left, and then back to the start. And then you could use edit points to adjust their position until everything lines up nicely. So I probably want those to be straight. But now if I click over here, we can see that shape is good. I'll click on this one. Because of the mode I'm in paint properties rather than select properties. So, I mean, be careful about that. But we can click here on the drop down and flip horizontally if we have this selected. Okay, let's see. What do I want? Rotate left, actually. Okay, there. Now we have the right one. I click over here. Okay, and that's good. You can also zoom in a little bit, and you can see these lines don't perfectly line up, so we probably want to edit that. So I will move this over a little bit more until it's right. Click over here one more time. Move this one down so that it's kind of a square rectangular corner. Okay. And I'll copy over to here one more time. And then let's flip horizontally and then click. Okay. So those ones are good. Now let's reset to default tile shape. Click here. Edit the points. Move these up. Something like that. Click here one more time. So you can see that doesn't line up. That's not good. You definitely want them to line up so your character's not getting stuck on random invisible walls. So click here one more time. Let's go up a little bit more. And then click. Okay, that looks good. And now let's click here and then rotate it. So rotate to the right. Click. And okay, there we go. So now we have the collisions for this entire cliff done. And if we hit play, we should not be able to enter from any side, which is great. So that did take a little bit more work, but by properly setting up the tile set collisions, I can click on player cat and just drag him into here, hit play, and I should be able to walk around up there, as you can see here, but I can't walk off the cliff. So now I have the illusion of having high ground and low ground, and I would need something else, kind of like the staircase tiles, in order to get up here to use this high ground. So a quick thing I want to point out is that if you have the move tool, you can actually accidentally move the tile map quite easily. So I'm going to Control Z that. And what you might want to do is lock the tile map in place at the transform 0, 0 so that you don't move the entire map. So if you just click on tile map and lock it, and now if you try to move it, you can't, but you can still paint on it. So if we go back to selection mode, click down here for the pencil tool, select what you want to paint, and then click over here, you can still do that. So I'm going to draw more top cliff areas. Let's just replace the tiles there. So as you can see, it is a little bit glitchy still for the alpha version of Godot 4. But let's go ahead and just kind of get this made. So that, and then we'll need those. But for this corner, I think you need this tile. So let's just add that in there, and that can work. So everything else can just be the tiles we already set up, I think. Eraser tool for this one down here. And let's add in the staircase tiles. So let's paint that in. And so now if we hit play, our character should be able to walk out of here, but not onto here for any spot, which is really cool because now we have the illusion of having two levels on our game. You just need to control the collisions and make sure that you use something like a staircase when you're going up the ground. Of course, right here, this tile, we may need to add a collision into that if we want. But aside from that, that is working pretty well. So I am going to remove that one tile there real quick. And let's go ahead and save the map. So another thing we might want is a follow camera that will actually follow our player around. Because right now, the player could easily run off the map like this, and it can come back. Some games would actually just have the camera be static and then change when the character switches to another level, like your Zelda games. But if you want a follow cam, which is totally legitimate, we can add one to the game level really quick. So I'm going to right click on game level, add child node, and this is just the root 2D node, by the way. So camera 2D, and then we need to point the camera 2D at something. So first I'm going to set it to current, so this is the active camera. Then I'm going to right click on the player cat in the scene, add child node, and then look for transform, which is going to give us remote transform 2D. So this gives us a location that we can assign to another node like the camera for it to look at. So create, and then where remote path is, hit assign, and then choose the camera in our scene. Now if we hit play, the camera is going to follow our character around. So as it is right now, it's just perfectly staying on top of it with no smoothing or anything. If you hit close, you can go to camera, and there are settings you can change for that, like smoothing enabled. If we hit play now, you'll see that this is a little bit different, but you can also see it's kind of glitchy when it comes to pixel art. So the easiest way is just to have that off. So to go ahead and speed up setting up these cows a little bit, I went ahead and wrote part of the script in advance. So let's talk about it. First off, one way of setting up states is to use an enum variable. So this can basically tell you what a object like a cow or a player is doing, and you can set up different states, different actions that that object should be doing at any given time. And then just like the player, the cows will have a move speed, which I'll actually lower a bit more there for the default. Just like before, we got access to the animation tree and the state machine inside of the animation tree so that we can change animations. Haven't done that yet, but we will. And then you have the move direction and the current state variable. So the current state variable uses the enum type up here, and we have the default of cowState.idle. But when the cow decides to move, we'll change the state into cowState dot. And actually, we do want to set that variable here. So current state equals cowState dot walk, and then I'll copy paste that down here as well, cowState dot idle. So let me explain why this pick new state function is a little different from the other one. The idea here is that whenever the cow is done walking, it's going to start idling. So we need to set up a walk timer and an idle timer. And when the idle is done, it's going to move into walk. And when it's in the walk state, it's going to move. Otherwise, in the idle state, it's going to stand still. But right now, we have a select a new direction function. So whenever it starts moving again, I want it to select a new direction. So we have that occur at the start. We just randomly generate either -1, 0, or 1 for the move direction for the X and Y. And then we get a random direction from 1 of 8 that the cow will try to move in. And of course, just like the player, we just use move and slide. You have to set the velocity, move direction times move speed. And that's pretty much it so far. So if I go ahead and hit play, you'll see that the cows decide to move when the game starts. This one didn't, because I guess it generated a 0 for both of its randoms. But the other ones definitely are. And they're going on forever and ever. It's also not displaying the right animation there. So let's set up pick new state here, so that at the start, it's going to actually display the walk animation. But also the names have to match what we have here. So I'm going to put walk right, and then this should be idle right down there. So this is going to switch from the default of idle immediately into walk right. So let's hit play and see what happens. So they are actually showing the walk right animation. The other thing we should do is flip the sprite when they're walking to the left. So I'll do if move direction dot x is less than 0, then I'm gonna make sure that the sprite direction is left. So to do that, we have to get access to the sprite. So at onReadyVar, sprite we'll say is equal to $sprite2d. So down here we'll do sprite.fliph. So in the sprite we have that fliph property. So if we do sprite.fliph, and we'll set that equal to true. Otherwise, or else if move direction.x is greater than 0, then we'll set the fliph to false. If it is 0, then we haven't actually changed to one direction or the other, so we don't want to mess with that fliph. So let's hit play and see if that kind of works. So they're all walking to the left this time. Let's hit play again and see if we get one walking to the right and one walking to the left. So by default, the sprite is set up to face the left. So that's actually correct right now. If we click on Cal, I can go down to the sprite and turn off fliph. Let's hit play one more time. Okay, and now the cows are facing the right direction when they move. And I only really want them to pick a new direction when it changes to the walk state. So I can just take this select new direction down here to cow state to where we change it to the cow state walk down here. Change to walk state, and then down here will be change to idle state. So when the cow decides to stop moving, we don't pick a new direction. If we hit play, it's still choosing the direction correctly. Okay, so next up, let's set the timer so that the cows can stop moving at the right time. So I'm going to right click on the cow node, add a child timer, hit enter. So the wait time is set to 1 here. That doesn't really matter because we're going to set that in code. So let's click on edit, and then let's add some more export variables. Export var idle time, that'll be a float, and defaults to 5 seconds, matching our animation. And then add export var walk time. Let's do float and say 2 seconds. So whenever we enter a new state, we're going to start a timer with these values. The timer node we have to get reference to on ready. So at on ready var timer equals $timer. Okay, so now what we want to do is come down here. When we change the state, we want to start the timer. So timer.start, and we're going to put in the walk time value. So walk time. And then down here, timer.start, and we will do idle time. Okay, so you might be wondering, after we start the timer, how do we know when it's done and do something when it's done? So if we click on timer and we go to node next to inspector, there's actually this timeout signal. Objects like a timer will be able to emit a signal when something happens. In this case, the timer reaches 0. And if we connect this to the cow script, then in the cow script, we can on timeout do something. So all you need to do is double click this signal, timeout, and we connect it to cow. So we're going to generate this new receiver method on timer timeout, which means when the timer sends a signal, we respond to that in the cow script, and we run whatever on timer timeout is. So connect, and what we're going to want to do is pick a new state. So I'm going to do pick new state. Okay, and honestly, that might pretty much be it. Let's go ahead and hit play and see what happens when the cow has walked for a couple seconds. So this cow's actually idling now, and this one is as well. We didn't stop the moving, but the animations are switching, so this is almost working. Let's hit stop. And I guess what we have to do when we get here is stop the moving. So we can either come down here and set it so that the move direction is 0, 0, and the cow won't move. Or what we can do in the physics process is only move if we're in the walk state. I think that makes a little bit more sense. So if current state is equal to cow state dot walk, then we're going to do this stuff, and that should be 2 equal signs because we're comparing, not assigning. And otherwise we do nothing because we're idling. So let's go ahead and hit play and we'll test this out. So let's see, do our cows stop? They do indeed. So did the cows start again? Oh, there's our little blink animation. Okay, so the cow obviously not so smart with the walls. That would require a bit more time to figure out for sure. But the cows are kind of working as like just a random NPC in the game. Also, I did add in a collision shape here. So the cows, you can't just walk straight through them. Now you might also see that when the character's down here, it doesn't exactly sort the cow's position with the character correctly. So that's another easy fix. Let's go back to the game level. And for all the objects in this scene, I'm going to click on game level and go to the inspector, down to ordering, and just check Y sort enabled. So what this will mean is that every object in the game will sort on its Y position, which is, I think, this little crosshair here. And you can customize that for each of your characters by offsetting your sprite if it's not exactly sorting from the proper position. But let's test it how it is right now. So I hit play. Let's try to go below the cow. And our character's displaying below the cow correctly. What about above the cow? It seems to be working. Below the cow. And then above the cow. So we know the Y sorting is working because depending on our position, it either shows in front or behind. So let's add some extra objects to our game, I suppose. So to make my life easier, I'm just going to drag this chest PNG onto the screen. You'll see this makes it a child sprite of the game level. So if we click on chest, and then we do the animation, let's see, 5x2 for the V frames, and now we just have 1 frame. So I'm going to right click on this chest, and then I'm going to do save branch as scene. And let's create an objects folder. So create folder objects. We have test.tscn. I'm just going to save this in here. And now we have another scene we can just jump into, but it's already created inside of our scene. So let's just jump into the editing of that scene and add, let's say, a collision shape 2D. And we're also going to add a static body 2D because this object is not supposed to move. So only things will run into it. Now, I think you do need to bring the collision shape under static body. Yeah, so that the static body recognizes its collision shape. Now, collision shape 2D, let's add the shape. Click over here and rectangle shape. Hopefully I'm not going too fast. This is all just kind of redoing what we did earlier on in the video with like the main player character. So we have a collision shape, we have an object. We can go back to the game level. And now if you want to create a whole bunch of these chests, just select the chest from the scene, hit Shift D, Control D, and then pull the copy out, selection, and then you just pull it. So Control D, now we have another chest. I can position that there. This one can be over here. And yeah, we can put that there. So let's hit play. And we can go ahead and collide with these chests. We have the moving cows, and we have these chests over here. Now, they currently don't do anything, but they're a random object in our scene. So we could really easily just create extra objects just by expanding the object folder. I'm going to duplicate this chest scene, right click on it, duplicate, and I'll just call it furniture 1 because I don't actually know which furniture is in the basic furniture pack. So if we enter furniture 1, let's drag the basic furniture into the texture here. And I'm going to reset the H frames and the V frames because these aren't really meant to be animated. They're just single frames. And instead what you can do is you can use region in order to select the area where the actual furniture is in this image. So I'll enable region here. And then, let's see, we click edit region, snap mode. We'll want to do a grid snap, I think. I'm going to set this to 16 by 16. Hopefully that's right. And then you just select the squares here from the grid that match the object. So if I want a bed, I select this one and drag it down to the bottom left here. And you can see because of the grid snapping, it's really easy to grab this. So if I click close, now we have a bed. I'm going to rename this to be bed. And let's edit the collision shape. So I'll click on collision shape and just drag this to where I think the player should not be able to enter for the bed. Might leave the top a little bit blank there because maybe we want to give the illusion that the player is, you know, just right behind the headboard. So not necessarily everywhere on your sprite is a collision area. So if we save that, let's actually rename the scene to match the object name, bed. Okay, and if we go to the game level, I can just drag this in. Didn't seem to actually work. Huh, what went wrong? Okay, so let me hide the tile map. What's wrong is the offsetting position. So what's wrong is the transform position. So let's actually jump into the chest scene, and you'll see in transform, the position is way off. That's because I created it by dragging it into the game level scene. So if we reset the standard position, Control S, you'll see that the positions of the chest are still there in the game level. That's because these are created as a copy from the base chest scene. So it's an instance of the chest. So that means that their values can be different. So if we look at the transform here, you can see the values are different for each one. But the bed, when I duplicated the scene, it still has those crazy positions. So let's jump into the scene. I'll click on the root node, reset the transform position. If we zoom out a whole bunch, it should be back here at the crosshairs. Control S to save. Let's delete the bed from the scene. Right click, delete node. Okay. And then drag the bed into the scene. And now it's going to be placed as you would expect, right at the cursor. So that is much more helpful. Now I'm going to Control Z a few times because beds don't make any sense here. So let's just see what else we can add to the game level. Let's try adding a wooden house. So I'll do that in the tile map. So, and I'll enable the view thing there so we can see the grid and the tile map. We can paint on the top ground layer. I'll click on wooden house and let's see what we can come up with by using these tiles. So let's select these tiles here. Oh, paste a roof in. We might actually need more layers. So I'm going to hit Control Z. Let's go down to layers for the tile map. So I'll add element here and I'll just call this the roof layer for now. Z index I'll make that a 5. So that should definitely show on top of anything else like the base frame of the house or the player. So let's paint the roof on. I'll select these tiles all at once and just put a house over there. Then let's go to top ground and I'll put the walls of the house. So let's just kind of paint those in here. There we kind of have a frame. I can also do base ground here for the underlying tiles. So let's create those. Okay, so now if I click on game level, we can see how it all comes together. This is 3 layers all at once creating the house. Obviously, needs a little more work to make it look like a real house. So let's go back to the roof layer. Take the edge here, put it here, and these tiles go there. Okay, and we'll need more roof center tiles, then the edge tiles, and then the bottom roof, and the edge of the bottom roof, and over here. Maybe we even need to go one more level here. Totally sure. So we fill that in, and we'll want a door, so I'll put that on top ground. Let's get a door. Then on base ground, delete the tiles which shouldn't be there. Then let's put this one here, which should. This is kind of glitching over here. So that should be this one. And you can probably tell the tile placing system is a little glitchy right now from what I can tell. That's probably just an alpha thing. So hopefully in the future it works a little nicer. So let's see, click on game level. It almost looks like a house. I mean, I think the problem is I did not add these down here. So yeah, okay. Yeah, that should be it. Okay, so roof. Let's create a line from here to here and then paint that and right here. So I kind of created the house over here. I'm going to click on Tilemap and let's actually just copy this to a different location as well. So you have to do this for each layer, I believe. And then I'll just drag these tiles, Control C, Control V to paste them in, and I can left click over here. And if we switch to top ground tile, I can select these, Control C, Control V, paste them in over here. You might have to do it a couple times to get it right. Yep, there we go. And then roof. So I'll select all the tiles, Control C, Control V, paste them in. And there we have a second house. Now what you'll probably want to do, once again, is to make these tiles actually collidable. So click on Tilemap, Tile Set, go to Wooden House, zoom in, Paint Tool, and we're going to do Physics Layer 0. And I'll just do the walls. So let's make all of these collidable, clicking on all of the squares that need it. And then I'll use the Edit tool to actually adjust it. So let's pull this in to over here. And then I'll click here, and I'll copy that down here, and one more time. Now let's click over here, and then I'm going to flip it horizontally. Click, 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 and we have our collisions made. So let's go ahead and hit play and test that out. So let's go down here, and we can't go past the house, but we can go a little bit behind it, which is cool. Because the roof tiles are not the collidable part, so that's actually working pretty nice. Now, if you wanted to, and this is going to go beyond the scope of this tutorial, but you could animate the door. I do see in the tile set that it has the animation frames for that, and you could switch levels as well. So the last thing I was doing for this series was just to spend some time creating fence collisions and then adding fences around the map just to create a border for everything. Doing that basically the same way as any of the other tiles we created earlier, like the house or the walls of the cliff. So that basically gives us our result. Having a walkable character with follow cam, cows that move around the map, several objects that we can collide and interact with. And that's pretty much going to be it for this crash course on Godot 4. So I've been Chris. I hope all of you learned a lot from this series. If you watched all the way to the end, thank you so much. And I will see all of you in my future video content.